All right, 2.6. It's very similar to 2.5, but now things are going to get a little bit more interesting, which is nice, okay? Let's take a look at this. Just like we did with 2.5, when I started doing a multiplication, applying the distributive property to see where those trinomials came from, I'm going to do the same, and then we're going to analyze how it goes so then we can understand how the reverse process goes. This case is a little bit more complex, so I'm going to teach you a technique. If you learn the technique, that's going to be totally fine. All right? So let's go for it. This type of trinomial, first thing, has to be a trinomial. Second thing is degree 2, which means that the highest degree in terms of exponent is 2. Well, we can eventually apply it to even exponents, but let's just keep it simple, all right? So the thing is, and the difference with the 2.5 unit is that now the quadratic term has a coefficient different than 1, right? But trust me, it's easy. Just pay attention to the process and you will see that it's really simple, okay? Well, again, let's begin with, I introduce you two factors. We have this factor, 2p plus 1, and then then it's multiplied by 3p minus 2. So let's proceed and do the multiplication. Again, as usual, and you're experts at this, you do this thing first. So it's 6p squared, and this is negative 4p. And now, this times this times this, right? This is going to be 3p, and this is going to be negative 2. As you can see again, linear terms have to be combined, so we will have a 6p squared, negative 4 plus 1, plus 3, is going to be, this is going to be a negative p minus 2. So this is the resulting trinomial we obtain after we multiply these two factors. Now, let's think about this. If I gave you this trinomial and if I'd say factor this trinomial, you are going to use this technique, and eventually your factors are going to be these two. The thing is now, well, how do I go from here to here? Well, let's work things out. Whenever you have this type of trinomial, when the coefficient is different than 1, pay attention to this. You're going to do a little change compared to the one we had before, and then you should be good. Look at that. You're going to take this coefficient and the constant, and we're going to multiply them, right? So this times this is a negative 12, all right? Keep in mind that what I just did to this was multiplying it by 6. It means that I modified the expression by multiplying by 6. So eventually, if I want to fix things, I will have to divide by 6 in order to maintain the same expression. Again, I multiply by 6, so eventually I will have to divide by 6. But I am using this trick because it's going to help me solve this, factoring exercise. So how does that work? Now I have negative 12, and what is the coefficient here? Negative 1, right? Okay. So similar to what we did in 2.5, we're going to think about two numbers that when multiplied, now you get a negative 12, and when added, you get negative 1. What are the possible combinations? Well, there might be many, but I'm going to give you the right one, right? In this case, it's going to be negative 4 and 3. When multiplied, you get negative 12. When added, you get negative 1. So, here's the thing. What we're going to do is this. We're going to distribute this time. And again, just some techniques. We're going to have 6p and 6p. Believe me, just do it. We will fix it, right? 6p, and 6p. And now we're going to assign each of these numbers. -4, +3. But remember, we multiplied by 6, we changed the expression. So now we have to return, we have to get back. So if you multiply by 6, now you're going to divide by 6. Yeah? We're going to get back from that multiplication by 6. How does this work? Pay attention. We are going to use this 6 to simplify this expression. But this 6, how can I do this? Well, I could just do this division here, but I will have a 1/2 here. It could work, so that could be one of the solutions, but it wouldn't be like the best thing for us, right? So the best way to do this is, okay, 6 is also 2 multiplied by 3, right? 2 multiplied by 3. So what happens now? This 2 is going to be able to simplify this term here. And this 3 is going to be able to simplify this term here. How? Well, pay attention. 6 divided by 2 is 3. 3p. -4 divided by 2 is -2. Okay? And now, this. 6 divided by 3 is 2, but it's 2p. 3 divided by 3 is 1 plus 1. Did we get the same thing? Yes. So if you want to replay as many times as necessary so that you know what just happened, okay? I will summarize it. First thing I did, multiplied the coefficient of the quadratic term by the constant, and I got this -12. I had to find a couple of numbers that when multiplied you get -12 and when added you get a -1. I found them, but since I multiplied by 6, now I'm going to get back and divide by 6. This division by 6, it's not going to happen that way all the time, but I had to split it this way so that I could simplify both of these terms and eventually get to what we had initially. Replay as many times as necessary, and I'm going to, in the next video, solve 2 exercises so you see how it works, okay? Pay attention. You have to be very concentrated, okay? And I know you can do it. You can do it.